Good morning, grade 10s. I hope you guys are all doing well and that you had a great public holiday yesterday. Today we are going to be starting with graph interpretation, so it still forms under the section of functions, but it's just the last little bit that we are going to do under functions called graph interpretation. So before we get started, to answer the question, what is graph interpretation? Graph interpretation is going to test your understanding of the different types of graphs and what they represent. So in the past, for example, say we were working with a parabola, you would be told it is a parabola, you would have to maybe find the equation or maybe find the x and the y-intercept, but it would be an isolated graph. It's not going to be the same with graph interpretation. What will happen is you will be given two or more graphs on the same set of axes. So for example, they'll give you maybe a straight line, a parabola and an exponential graph, and these three graphs will intersect each other, they will share coordinates, and basically they are going to ask you questions about these types of graphs. So what they would usually do is, say for example, if there are three graphs, they might give you the equation of one and you would have to find the equation of the other two. They might ask you things like calculating the x and the y-intercepts. They might ask you for things like what is the turning point of a parabola, what is the equation of an asymptote, what is the axis of symmetry, find the length of this line, and there's many different questions that they can ask. They can ask you for what values of x are the graph increasing or decreasing. They can ask you for the domain and the range. They can ask you at what point is the one graph greater than the other graph. So there are lots of different questions that can be asked when it comes to graph interpretation. And basically, you are going to need to know all the specifics for each four graphs. You're going to need to know how to find the equation for each graph. You're going to need to know where the asymptotes are, how to find the y-intercept, how to find the x-intercept, how to find the turning point, what does the q value represent, what does the a value represent, what shape should the graph be, what direction should it be going. These are all things that you are going to have to know before you even start with graph interpretation. So like I said, you're going to need to know each graph individually, all the characteristics of each of the four graphs, and then when it comes to graph interpretation, they're going to put them all together, they're going to combine it, and they're going to ask you lots of different types of questions. Now, like I said, it can become very confusing, but if you know the specifics about each type of graph, it will help you a lot to not get confused. If your knowledge is vague and not so sure, then it's going to become very difficult to get confused. So what I'm trying to reiterate is that you need to know the specifics of your four types of graphs. Study them, know them well, and then when it comes to graph interpretation, it would be a lot easier. You'll see there that I've said the only way to succeed with this section is to practice different types of questions, because you can never know for sure what graphs will be asked. So you don't know, is it going to be a parabola in a straight line, or will it be an exponential in a parabola? You can not predict what they are going to ask you or what they are going to give you. So you need to practice so that you can familiarize yourself with the different types of graphs, with the different types of questions, with the way they word their questions. So yeah, practice makes perfect in this section, and you'll see over the next 3 days we are going to be doing quite a bit of practice. Before we get started, just a few things to remember over and above everything else that you have already learned. It's always going to come up that they ask you for the x and the y-intercept. So please remember, to find the x-intercept, you make y equal to 0. To find the y-intercept, you make x equal to 0. For a linear and a quadratic function, the q value is your y-intercept. So if, for example, it is 2x plus 3, you know your y-intercept is going to be at plus 3. For a hyperbola and an exponential function, the horizontal asymptote is your q value. So if you have an asymptote at positive 4, you know that your q value is going to be plus 4. Then what is going to come up quite a bit is that they are going to give you the equation, say for example, of a straight line, and they will say to you at point C, x is equal to 4, calculate the value of y. So they will give you one part of a coordinate and you need to find the other parts of the coordinate. So what you will need to do then is you will substitute the x value into the equation of the straight line in order to find the y value. Or if they give you the y value and not the x value, you would substitute the y value in the place of y to find the value of x. So that is going to come up quite a lot. You'll see in the upcoming activities where they give you half of the coordinate and you need to find the other value of the coordinate, and you'll see that it works a lot on substitution. And then the last thing just to remember is that the length of a line segment can never be negative. So if you have, for example, point C, which is at -3, where your x value is -3, if they ask you for the length of line C to the origin, you would say it is 3 units. It wouldn't be -3. Distance or length cannot be a negative value. But because it sits at -3 on the x-axis, you know that it is 3 units in length. So just remember that length or distance cannot be negative. Okay, so moving on to an example now. You will see this comes from your textbook and it's on page 175. It's question 1 of the mixed revision exercise. And just a couple of things to point out before I actually do them with you. You will see that you have been given 2 functions there. You have a parabola, which is graph F, and you have a hyperbola, which is graph G. You can see that there is a coordinate, which is 1 and 3, and you can see that coordinate is where the 2 graphs intersect. You can also see that you have a horizontal asymptote at the point 2. You can also see that that point 2 is your turning point or your minimum value of your parabola, and it forms the asymptote for your hyperbola. So these are just a couple of things that you should be seeing and should observe before you even look at what the questions are. So I'm going to do it in a separate video now where we are going to actually go through this question for question. It will be quite a long video, so just bear with me and please have the questions with you so that you can follow with me as I do them. Right, good morning grade 10s. So as you can see, I'm going to do question 1 from the revision exercise with you. I am going to have to move back and forth between the question and the answers just so that you can see nicely. So the first thing it says in the diagram below, the graphs of F and G are shown. So you can see F is your parabola and G is your hyperbola. It says the graphs intersect at 1 and 3, so that point there is where the 2 graphs cut each other, and that's 1 and 3. So what I'm going to do is I'm just going to highlight my parabola so that I know which one I'm working with, and I'm going to do my hyperbola in a different color just so that I can see certain things very clearly. So the first thing they say is determine the equation of F. Okay, so we're looking at number F, so 1a. The equation of F, you should already see that F is a parabola, so the standard form would be y is equal to ax squared plus q. So that's the standard form of your equation. And then you need to see what is given. So the first thing that you can see is that this value over here, your minimum or your turning point, is 0 and 2, and it's your y-intercept. So you should remember that your y-intercept is your q value. So your y-intercept equals your q value, so therefore your q value is going to be 2. You can see the graph has shifted up 2 spaces. The next thing that they give you is a coordinate, so you've got the point 1 and 3. And that's enough for us to find the equation. So what I'm going to do is I'm going to replace q with 2. So I've got y is equal to ax squared plus 2. And yeah, I'm going to substitute in my x and my y value in my coordinate. Instead of y, I'm going to say 3 is equal to a. Instead of x, I'm going to say 1 squared plus 2. So I get 3 is equal to 1 squared is 1. So I get a plus 2. I want a on its own. So I'm now going to subtract 2 from both sides. So 3 minus 2 is 1. So therefore I get a is equal to 1. And from there I've now found my q value and I found my a value. So therefore I can just plug those back into the standard form and get the equation of my line, of my parabola, sorry. So therefore y is equal to a is 1, so I don't need to write it. So it's just going to be x squared plus 2. And that would be the standard form of your parabola. Okay, the next question says, determine the equation of g. So same process, we're going to look at g. So what I'm going to do, excuse me, I'm just going to put that there so I can move it up. So the equation of g, my standard form of a hyperbola, y is equal to a over x plus q, and then I need to see what has been given. So you can see that this over here is my horizontal asymptote, which means that the original graph shifted up 2 places. Now we know that our horizontal asymptote is the q value, so therefore you can say that your q value is 2, and again we also have been given a coordinate 1 and 3. And what we're going to do is we're going to substitute that back into our formula to find the equation of our graph. So I'm going to say y is equal to a over x, and q is going to be plus 2. I'm now going to substitute the x value and the y value. So my y is 3 is equal to a over x, which is 1 plus 2. And the goal there was to get a on its own so that we can find the value of a. And you can see there that anything over 1 stays 1. So 3 is equal to a plus 2. I want a on its own, so I'm going to subtract 2 from both sides. 3 minus 2 is 1, so a is equal to 1. So now you can see I've got my q value and I've got my a value. I can plug them back into my formula, and there I will have the equation of my hyperbola. So it's going to be y is equal to, my a value is 1 over x, and my q value is 2. So that is my equation for g. Alright, moving on. Number C says write down the coordinates of the turning point for f. So that's quite nice and easy. You can see that your turning point happens to be your y-intercept. So there's no calculations there. All you would need to do is write down your turning point. I'm just going to write TP, turning point is equal to, and it's this point here. So the x value is 0, the y value is 2. So that is your turning point. Moving on to D, write down the equation of the axis of symmetry of f. So here is graph f there. Your axis of symmetry is actually your y-axis. You can see that that line cuts the parabola exactly in half. So your axis of symmetry would be this line here, which is x is equal to 0. So at 0 there, x is equal to 0, which gives you your y-axis. So I'm going to actually just write there that your y-axis. Okay, moving on to E, it says write down the equation of the horizontal asymptote of G. So we're looking now at our hyperbola, and our horizontal asymptote we already established is that line there, and you can see that it is y is equal to 2. So our horizontal asymptote would be y is equal to 2, and it is this horizontal dotted line. So you're just writing down the equation. Number F says write down the domain of f and g. So I'm going to do the domain of f to start off with. So we're looking at this one, we're looking at our x values, and that arrow shows that this graph goes up to infinity and up to infinity there. So the domain of f, our x, is an element of, and you would see it goes all the way from negative infinity to positive infinity. So that's the domain for f. Then the domain for g, say x is an element of, and for g, you can see that the x values go all the way to infinity, but then they stop at 0. So it doesn't include this y-axis here. So it's going to be negative infinity all the way to 0, but it doesn't include 0, so it's going to be a round bracket, not a square bracket. And then it starts again from there. It goes from just before the y-axis all the way to positive infinity. So again, it's going to be a round bracket and all the way to positive infinity. So it doesn't include this y-axis here. And that y-axis, actually, you'll learn next year, becomes the vertical asymptote. Okay, then number G says calculate the range of f and g. So we're going to start off with a range of f. So y is an element of. So you can see if you go up like that, we're looking at our y values. You can see it starts at 2, it includes 2, and goes all the way to positive infinity. So it's going to start at 2 square bracket because it includes, and it goes all the way to infinity. And then the range of g, y is an element of, so the range of g, you can see it goes from negative infinity all the way to 2. It doesn't include 2, it doesn't cut 2, so it's going to go round bracket, negative infinity, all the way to 2, but it doesn't cut 2, so it's round. And then it starts again there. It starts just after 2, so it will never cut that asymptote. So it won't include 2, but it will be just above 2, so, and then it goes to positive infinity. So it's going to be 2 and then positive infinity. So that's the domain and range. Okay, I'm just going to turn to the next page. Moving on. Where were we now? Okay, we did the domain and range. So number H, question 1H, for which values of x is the graph of f increasing and decreasing? So you can see for graph f, the parabola, where is x increasing and decreasing? So you can see that over there the graph is going down. So you would say that x, f is decreasing where x is smaller than 0. So there it's going down where your negative values of x. And over there you can see your positive values of x, and it is increasing. So f is increasing where x is greater than 0. So your positive values of x, that is increasing. Next, number I says, determine the coordinates of A. So we're looking for point A, and what can you tell me about point A? It is the x-intercept of our hyperbola. So we found the equation of our hyperbola was y is equal to 1 over x plus 2. That was the equation of our hyperbola. We're looking for an x-intercept. So to get the x-intercept, we need to make y equal to 0. Okay, so what we're going to do is we're going to say 0 is equal to 1 over x plus 2. That positive 2, I'm going to subtract from both sides, so it's going to become negative 2. So negative 2 is equal to 1 over x. I want to get x on its own now, so I'm going to times those together. So it's going to become negative 2x is equal to 1. And now I want x alone, so I divide by 2, divide by 2. Actually divide by negative 2, sorry about that. Those cancels out. Now I've got a positive x all on its own is equal to negative a half. So they've asked the coordinates of A. So the x value is negative a half and the y value is 0. Now just look on your graph, does that look right? It is on the negative side, and yes, it would be right. Okay, then number number J says write down the equation of the graph formed if the graph of f is translated 3 units down. So our graph of f, this is number J1, the graph of f was y is equal to, what was it, x squared plus 2. So they're asking if that graph had to move down 3 spaces, so 1, 2, 3. So what you're actually doing is you're subtracting 3 from your q value. So then the new graph would become y is equal to x squared, and 2 minus 3 gives you minus 1. So that would be the new equation. Then J2 says if it was reflected about the x-axis. So that means if that whole graph had to flip down there. And what you should see is that first of all, your x is going to become, your a value is going to become negative. So it's going to become y is equal to negative x squared, because it's going to be there. So it's going to come down like that. And then you should also see that it will go down 2 spaces, 1, 2. So it's going to be minus 2. So if you compare that to the original, y is equal to x squared plus 2, all you're really doing is timesing it by a negative, and it becomes negative x squared minus 2. So you're reflecting it about the x-axis, which means you're making it a negative graph. So what you're really doing is you're just timesing it by a negative, which will give you negative x squared minus 2. Alright, grade 10s, I hope that video helped you. I hope it made sense. I know it is a lot to take in. It's a lot of different concepts that are all being put together, but that is the point of graph interpretation, is combining everything and making sense of it. So if there's anything that you did not understand, please ask your teacher. But for now, the homework for today will be to finish off the exercise which I started. So you would remember that I've done question 1. You are now going to do question 2 on page 175, and it's the mixed revision exercise. So you're going to do question 2 for me, and you'll see that in question 2 you are working with 2 straight lines, an exponential graph, and a parabola. So it is going to get quite complicated, but just take it one step at a time. Go back to your notes, go back to your work. If there's something you're not sure of, try and figure it out first, so that you can actually learn while you are doing this. Guys, please remember, if you're stuck, if you need help, please contact your teachers. That is what we are here for. I hope you all have a lovely day, and I will chat to you tomorrow.